for our final function of section 3.5, we want to look at f of x equals x squared minus x minus 12 divided by x minus 4. First off, huh? Does it have any horizontal asymptotes? No. Does it have a slant asymptote? Yes. But before you find the slant asymptote, let me point out to you that if you factor the top, you can see very quickly that the denominator is not a vertical asymptote. What is it?
A hole.
It's a hole. It is a restriction. But remember, restrictions are either holes or vertical asymptotes. And this one is a hole. So it turns out this guy has a hole at 4 comma what? Very good question. Let's see. What's left if I cancel that? X plus 3 over 1, right? Y'all understand that? Okay. So this is what we call the unreduced function, and this is the reduced function. So it turns out everything went away. I didn't have a vertical asymptote. I didn't have a horizontal asymptote. I thought I had a slant asymptote, but it turns out the graph itself is acting like that line. Do y'all understand that this divided by this equals this? Okay, so if it factors and cancels, it's not a slant asymptote. Okay, some of you might think it is sometimes, but it isn't. To graph a hole, remember to find the y value, you simply plug the x value into the reduced function. That's where we get the 7 from. Now let's see if I can make this make sense to you guys. This function up here, this guy, is exactly the same as this guy, except for the fact that the original has a hole at 4, 7, and y equals x plus 3 doesn't have a hole. Do you understand that? Yes? Mm-hmm. That's how they operate. So all we have to do really is graph, very bad with the crayons, is graph y equals x plus 3 and then put a hole at 4, 7. So you graph the reduced function and then put the hole in, and that will give you your original function back. So if you have a hole, you actually just graph the reduced function, which is just a line, so we can do that very quickly. Y equals 1x plus 3. Here. And then up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on. Are you guys good with that? Yes? Yes. Okay, so there is my graph of y equals 1x plus 3. To have the graph of y equals x squared minus x minus 12 divided by x minus 4, all we have to do is go take the whole out. So go to the point 4, 7. 1, 2, 3. I can't count. 1, 2, 3, 4, 7. Right here. And you need to remove that spot and put a hole in its place. So take it out. And just insert a little hole there. And that is how you graph a function that has holes. Any questions? Joshua? You sure? You got it? Huh? Okay. Do you see that the x minus 4 canceled? Okay. What makes that 0 is the x value of the hole. So positive 4. And then once I cancel, I'm left with just y equals x plus 3. You plug the 4 into there, and that's how you get the y value of the hole. So any restriction that cancels makes a hole at that restriction.
So you don't draw the asymptote where the hole is?
There is no asymptote. It can't be a hole and an asymptote at the same time. It turns out that one was just acting as a hole. Let's pause for a second. If we want to find all intercepts of y equals x squared minus 16 all over x plus 2, how do you find an x-intercept?
Y equals y 0.
You let y be 0. So I want to know 0 equals x squared minus 16 over x plus 2. What's the only way a fraction can equal 0? Is if the top equals 0. The denominator equals 0 is a restriction, right? There's a restriction at x equals -2. But the only way for a fraction to equal 0 is if the top goes to 0. If you want to see it algebraically, think of it this way. If you put that 0 over 1 and you cross multiply, you get 1x squared minus 16 equals, what's 0 times all that? 0. Then you can solve it and find your x-intercepts. I'm going to factor it. And I can see that I have two x-intercepts. I have one at -4 and one at +4.
Couldn't you have just moved the 16 since this is a perfect?
Sure, you can solve quadratic equations a multitude of ways. So there are my x-intercepts. A lot of people get confused there, so I wanted to talk about it. Now let's talk about the y-intercept. To find the y-intercept, we simply let x be 0. So we get y equals 0 squared minus 16 over 0 plus 2, which gives us -16 divided by 2, which is -8. Got it? All right. Now tell me about the restriction. Where is the restriction? X equals -2. What's it acting as? Is it a whole or is it a vertical asymptote? Does it cancel? Does x plus 2 cancel?
No.
No. So that means it can't be a whole, it's a vertical asymptote. So if we look at it, not that I asked you to do this, but if we did factor it, we would see that it does not cancel. So it has to be a vertical asymptote of x equals -2. Got that? Okay, last thing. Tell me the domain of this function. What is it? The domain? No, it can't be all real numbers because it has a restriction. Don't forget. -∞ to -2, -2 to infinity. Good. Okay. I didn't want you guys to forget about domain because that is in this unit as well. I just wanted to go back over it.